Hello, my name is Nicholas Remidis, and I'm going to explain what the Higgs particle is. First of all, we're going to start at the beginning of our time, which was in Big Bang. Big Bang is going to be our point zero in this presentation. Then, we're going to go to present time. Present time was in 13.7 billion years after the Big Bang. Now, the Higgs particle was only present in the very first second of that time period. In that little lifespan, it did all his interactions with the universe. To understand better the Higgs particle, we have to talk about the Standard Model. The Standard Model is a theory that consists of 12 subatomic particles and 4 bosons. The subatomic particles are separated in quarks and leptons. Also, and then there is the bosons. The quarks are the top, bottom, charm, anti-charm, up, and down. The leptons are the electron, neutrino, the electron, the muon, neutrino, and the muon. Also, the tau, neutrino, and the tau. Then the bosons are the gluon, photon, and W and Z boson. Each boson has its individual force. The gluon is the strong force. The photon is the electromagnetic. And the W and Z boson is the weak force. Now, I'm going to show you how the Higgs particle interacts with all these subatomic particles. Now, the Higgs particle, we can describe it, it has the Higgs field, which is just like a broad area. And then the Higgs particles are multiple, so they're everywhere, which is just Higgs particle. Now, to better explain this, we're going to create it as a 3D diagram of a square. Now, in this diagram, we're going to have a tennis ball and a basketball. Now, let's think that here is like little lines, and inside here is the Higgs field. If we throw inside the tennis ball to go through it, there's not going to be a lot of interaction between the Higgs field and the tennis ball, which includes to less mass. So less interaction equals to less mass. Now, if we throw the basketball through the Higgs field, then we're going to have a lot of interaction, which is going to make a lot of mass. Now, to better explain this, how the basketball and the tennis ball get their masses, we're going to show in this diagram. Within the Higgs field, we have the Higgs particle. And then, for example, if we have the tennis ball, we're going to have the Higgs particles just roaming around, and then we're going to have a lot of Higgs particles close to the tennis ball to show that it gets mass. Now, if we had the basketball, we're going to have even more of Higgs particles around it because it gets a lot of mass. So we're going to have much more Higgs particles around it. And in that way, we understand that once something goes through the Higgs field, it gets mass because of the interactions with the Higgs particles. Now, to understand this and connect it to the Standard Model, the subatomic particles went through the Higgs field at that 1 little second after the Big Bang. So it's very important to physics and our world, because through the interactions of the Higgs field and the Standard Model, we're able to get mass, and if it wasn't for the Higgs field, then we wouldn't have mass in today's world, and we wouldn't even be alive.